Hello everyone and welcome to lesson 4-5, found on page 160. Compute with scientific notation. So what are we going to learn? We're going to learn to multiply and divide numbers in scientific notation. Add and subtract numbers in scientific notation. So we're essentially doing some basic computation, multiply and divide, and add and subtract using scientific notation. Here's a real-world link. The SR-71 Blackbird is one of the world's fastest airplanes. It is capable of traveling at a cruising speed of Mach 3, or 3 times the speed of sound. The speed of sound is approximately 760 miles per hour, so 3 times this speed. That's incredibly fast. Google it if you like, or YouTube it, and see if you can find a video where it shows how fast it flies. Okay, so here's how we're going to make a connection to what we've already learned. You can apply the product of powers and the quotient of powers. So you can apply the product of powers, meaning what you get when you multiply and what you get when you divide, the quotient. The quotient of powers or properties to multiply and divide numbers written in scientific notation. Now, what does this mean? As you can see here, we're going to use, we'll take one scientific notation times another scientific notation, and we're going to use commutative and associative properties so that we multiply the 3.5 times 1, okay? So we use associative property there, and then we will multiply the exponents together. So 10 to the power of 6 times 10 to the power of 9, as you see right there. Okay. For this one, we're talking about the rainforest, the Amazon. Scientists estimate that there are over 3.5 times 10 to the power of 6 ants per acre in the Amazon rainforest. If the Amazon rainforest covers approximately 1 billion acres, find the total number of ants. Write in scientific notation. So this would be the number 1 billion, 1 times 10 to the power of 9, which you see right there, and this is the number of ants. We're multiplying it because this is the number found per acre. Number of ants, and this is how many acres we have, 1 billion. So you multiply them to see how many number of ants we have, and the number that we get is 3.5 times 10 to the power of 15 ants in the whole rainforest, Amazon rainforest. It's quite a large number. Okay, so let's try these. Let's try 1A, B, C, and D. Let's try 1A first. So I've used associative property to regroup 1A, and I took the ones the 4.62 and the 8.15, and I put them in one parenthesis together so that now I can simply add the exponents here. So I know that this is going to give me 10 to the power of 14, right? Times 37.653. Okay, when I multiply 4.62 times 8.15, I will get 37.615. Now I have to change this to scientific notation. Now remember, we can only have a number in the ones place when it's scientific notation. So now I have to convert it to 3.7653 times 10 to the power of, it cannot be 14 because I have moved the decimal place over 1. So it has to be 15. Does that make sense? If it doesn't, please watch this part again. But remember that when we move a decimal over 1 to write in scientific notation, later on to move that decimal back the other way, and we moved it this way, when we move it back, that means we need to have 1 more power of 10. Okay, I will do B now, and I will you will have to do C and D on your own. Please, I will be checking for these when we get to class, so put a star right next to each one, 1C and 1D. Okay, because I will be checking those in class. Those are for you to practice on your own. In the meantime, watch how I do B. I use associative property to group the two mixed numbers, so I can multiply them, and I will group the base 10 with the exponent, right? Okay. Now I can go ahead. I know this one. I'll do this one really quickly. I have -8 plus. We add it when we multiply numbers, but it's -8 plus -3. It's going to equal -11, right? -11. So 10 to the power of -11. I can close that and ignore this, right? And now 7.53 times 2.93 equals 22.0629. Okay, but remember, I want to put this in one decimal place there, so I have to actually move it over to write in scientific notation. So scientific notation is going to look like 2.20629 times 10 to the power of. Now really try to think about this one. If I have to move the decimal, okay, one more time this way, because I'm going to, in the real answer, I have to move it that way. That means I get one additional power of 10. I have one additional power of 10. So am I adding a negative to this or taking away a negative? I am taking away a negative. So it's actually times the power of 10. If it's not making sense to you, draw the numbers out, write them out in standard notation so that you can see. So as I mentioned before, please do 1C and 1D on your own and we'll check it in class. Okay, now in example 2, we have two scientific notations written as a fraction, which means we're going to divide, okay, to find the 1. So you can see that we do the same thing, we do associative, okay, so that we divide the decimals together and we divide the exponents together. Okay, when we divide 7.56 divided by 3.15, we get 2.4, and then we just subtract here the exponents, so a minus 3, which gives us 5. And there's our answer, 2.4 times 10 to the 5th power. Okay, for this one, I want you to try 2A on your own while I do 2B. Now, boys and girls, if these questions that I've asked you to do are not done, you will not receive a completed grade. You will not get 2 out of 2 on the homework. Okay, so please, they must be done. This is for your own good. Okay, so moving on to 2B, what I've done is I've grouped them using associative property. Okay, and now I will divide here, and I will divide here as well, which means I have to subtract the negative exponents. I will use a calculator for this simply because it makes it a lot easier to divide at this point. So I will use a calculator, and this I don't need a calculator for because I know that when I subtract negatives, okay, I get a positive. So it's negative 9 minus 3. Minus 3 is plus 3, right? So I take away 3 of those negative and I get negative 6. So when I divide these two numbers, I get 0.49. So clearly this is not a scientific notation. I have to now turn it into a scientific notation, and you know the rules with scientific notation. I must have a number in the ones place. What do I have to do to this decimal to move it over this way? What do I have to do to it? I have to, oops, I missed something here. It's negative. Oh no, I didn't. I just moved it accidentally. It's negative 6. You see that? Okay. I have to multiply by a power of 10. Multiply, which means I need one additional multiple of 10. So this has to go from here to here. You understand what I mean? So later on, when I want to turn it to a standard notation, I'm going to have to count the number of places of exponent. In the meantime, I have to move it over to the right. Okay, so that means I have to add an additional negative exponent. Okay, I hope that makes sense to you. So now it's 4.9 times 10 to the power of 7 times 10 to the power of negative 7, sorry. Now I removed the parentheses because this is my final answer. Okay. You go ahead and try A, please. Example 3. Let's zoom in. In 2010, the population of China was about 1.3 times 10 to the power of 9. So that's 1.3 billion. According to the census data, the population of the United States was 308,745,538. I don't understand how they get so exact, but that's amazing. About how many times greater was the population of China than the population of the United States? If we want to know how much bigger this number is than this number, all we have to do is divide this number by this number, so we can see how many of these are here. Make sense? So that's what we do here. Okay? So we're going to now estimate the population of the United States to a nice rounded number so we can convert it to scientific notation. So we rounded it down to 300 million. You see that? 300 million. And we change it to the scientific notation. So now we're simply going to divide using this associative property and dividing these numbers together, as you see right there, and we go through the whole process and we get 4 times 10 to the power of 0. Now 10 to the power of 0 equals 1, right? So this is how it's written in scientific notation, but in reality it's just 4 times larger, right? 4 times 1 is 1. So China is 4 times greater than the population of the United States, or was, at least in 2010. Alright, let's try the word problem. Until 2008, the world's largest working cattle ranch is where they have cows and animals, was located in Australia. It was about 6 times 10 to the power of 6 acres. The largest ranch in the United States is 825,000 acres. About how many times larger was the ranch in Australia than the largest ranch in the United States? Now, 6 times, this looks like it's 6 million. Yeah, 6 million. So it's going to be about 6 times larger, possibly 7 times larger. That's my estimate. But how do we do this? I will take the number of acres in the United States and convert it to a scientific notation. Let's round this down to 800,000, which is 8 times 10 to the power of 5, right? 1, 2, 3, 4, 5. And now I have 6 times 10 to the power of 6 and 8 times 10 to the power of 5. I'm going to use associative property to divide these two, and then later divide these two. Okay, so 6 divided by 8 is going to give me 0.75 times, remember that this is subtracting, so I'm subtracting 5 minus 6, it's just 10 to the power of 1, or we can simply write 10. Okay. Now, if I were to solve this, right, to get a standard notation so I can figure out what this number really is, I multiply 7 times 5, so I'm going to get 7.5. 7.5. So we can say that the ranch in Australia is 7.5 times larger, or we can just say about 7 times larger. And that's your key answer right there. About 7 times larger.